Is everybody here a programmer? If you're not a programmer, give me a wave. For everybody who's not a programmer, give me a wave. Oh, cool. I'm so glad you're here. This will be great. So, readability, it's a little less obvious, I think, than we thought it was. There are some objective bits and some subjective bits, and the subjective bits are often less subjective than you think they are. So let me show you what we know now and how we understand it, and I'll get some code in front of you. Oops, is this not on? Oh, okay. So how we got here? There's an argument. And the argument, there is a delay. I might go to the keyboard. Okay, so I got in an argument. The argument went something like this. Hey, this code is readable to me. What are you complaining about? And I said, well, it's not very readable to me. Clearly, it needs some work. And they said, well, maybe you should be better at reading code then. And I said, well, maybe you should be better at writing code then. And this was in the 1980s. It's been a while. But that launched me into a whole career full of different ideas. This isn't the most important thing, right? I mean, you've got to make sure you're doing work that makes your customers happy. And by the way, we don't really experience code reading the way we do. I mean, some people read prose, you read novels, you read business work for entertainment. You probably read Harry Potter. You might read poetry, right? Do you ever just sit down and read code listings on your day off because you just love reading code from top to bottom? No, we don't experience code this way. Usually, if we're in the code, it's because there's some effect we want to make to the code. And then we have to collect enough information to be able to make the change correctly. So mostly what we do is we scan the code. So readability is of secondary importance to the ability to scan the code and find the parts that are interesting. And G. Paul Hill talks about this. He talks about code scanning being so much more important than code reading. We only have 25 minutes. I will leave that to G. Paul Hill. You can pursue that. It is important, though, that we can read code. At least that's my premise, and I would like to believe that it is so. But think hard about it. Scannability. If I can find the code I need to read, that's the big thing. So here's some code. And people suddenly looked at it. Okay. Now, we don't have to read this deeply and be able to interpret this in our heads to start forming judgments about it. So let's just take a couple of little questions. First off, how many of you skipped the comments and went straight to the code? Yes. Isn't that interesting? Okay. Oh my gosh, that's terrible. Well, that's a good reason. I had no idea the contrast would be quite that bad. Well, let's move along. Did you recognize this as Python code? Okay, some did. There's a data frame. Did you hang your understanding of the code on the fact that this is using pandas? No, some did. Okay, well, it barely uses pandas at all, and it doesn't really help you to know that. When did it start to bother you that you didn't know what was in the data frame? Yeah, right away, right? It would be nice that the name were not P. It would be nice if it was something like commit underscore df. Underscore df is standard for data frame. Do you know what a default dictionary is? Anybody? Okay, well, that probably wasn't very helpful then. And the variable's named D, which is kind of annoying. Did you hate to see the D and the P as variable names? Yeah. Does it bother you that there's no guard clause in case files is empty or has only one file? Didn't notice that. Tim, that's deeper than we had time to go. That's okay. Do you know combinations from itertools? No. How could we read this code at all? This seems like this might be unreadable code, but it's so small and simple. It's just, a variable and a nested loop with an if statement. It's clearly some kind of a filter. How bad can that be? If you didn't know default dict, did this plus equal of a number make you nervous? Default dictionary, by the way, if the element doesn't exist, it'll create one. And the default dictionary in this case is for a float. So the default float is a 0. Yeah, I see your faces. I had the same feeling. Okay, on a scale of 1 to 5, which happens to be the fingers on one hand, from 1, poor, to 5, excellent, how readable would you say this code is? Isn't that interesting? By the way, this code was written first in a REPL. If you're a programmer, you know what a REPL is. And then it was pasted into a function in a source file, and some comments were added, and a bunch of tests were written around it. In a REPL, you tend to make names ridiculously short because you're just sketching ideas, and sometimes you forget when you make them into production code to tidy up. This has been since tidied. What it does is not that interesting. It's part of an analysis suite that I have for making decisions and understandings about a source code base based on its revision history, so that you can see, well, the way we maintain this code is, when we maintain this file, we're likely to also touch these other 3 files that have a high strength of correlation. That's not interesting to you? I know, that's okay, but that's what it's doing, and it just doesn't look like that. So what would you say the greatest readability sin is? Well, it's kind of interesting because if you really know your library and you know the application, it is, but only if you don't know, which is cool, by the way. You're right, it's not self-explanatory in this context. Do you hear the beginning of a rumbling of something really important deeper down? I think you should. I'm bothered by the implicity. Not simplicity, but implicity. The number of things you need to know before this code makes any sense whatsoever. There's a lot of things that are implicit, expected to understand, that are not explicitly called out. That bothers me. And a lot of code is okay except for the implicity. That is one of the kinds of problems. Now, of course, all source code has meaning. That's pretty obvious, right? I mean, you compile it and then it runs and it does something. If it works, it clearly has good meaning. If it doesn't work, not so grand. It couldn't be compiled if it had no meaning. So maybe people should be better at emulating a computer when they read the code. If you can play compiler and you can play processor, shouldn't you be able to read all the code and it would be equally easy to read? Theoretically, yeah. How many of you are keen on taking on that particular challenge? Nobody, because we are humans, right? So maybe we should be better at reading it and digging out the deeper meanings, but maybe, maybe not. Maybe we need more compiler empathy to recognize how the compiler feels about the code. So I went to the dictionary and I said, how's readability work? And it said, okay, readability, it's legible and decipherable. I said, great, let's go to legible. It says see readable. Oh, okay, well, we still have decipherable. I go to decipherable, it says see readable. It's painfully cyclical. What the heck is readability anyway? So I found this website called readable.com. I thought if somebody knows, these people will know. They've named their business and their website after it. And they said a whole bunch of words. Well, let me pick out the words you want to look at. First one, readability is a measure of how easy a piece of code is to read or text. Big duh, obviously. Okay, let's go to this one. The level of complexity of the text, familiarity. Ooh. Familiarity. Do you know why that first piece of code was hard? Because you weren't familiar with the data and with the functions that it was using. Turns out that's really important, and we'll come back to that. Complexity should be objectively measurable, right? The number of operations, the number of operands, the number of paths. That's complexity, right? If it has fewer operations, fewer operands, fewer paths, it is obviously physically simpler. So that's pretty good. Familiarity, how objective is that? It's very subjective. It's rather subjective to the particular audience. I've bumped my mic in case, there we go. So it is subjective to a set of readers, a particular audience. And a different audience might not find it readable at all. How good are you at reading Finnish street signs? Well, how come you don't do Finnish street signs well? Because you don't speak Finnish. Or if you do, then you find them very easy to read, right? So that's an interesting thing. Then there's legibility and typography, which in us, for us, that's formatting and indentation. That probably matters. So the last bit says that readability is a key factor in user experience. Ooh. What is the user experience of your code base? What's it like to be someone who's trying to make a change? What a brilliant idea. Accessible content builds trust with your audience. Have you ever picked up a piece of code and you saw who the author was and you went, oh, crap. Oh, this is going to be a long day. Okay, I think we're getting something. There's something important hidden in here. So does it matter? Okay, well, first off, do errors ever arise from misunderstandings of the code? Yes, okay. Have you ever had to resort to the debugger in order to understand what the program's doing? How easily do your tools spot legitimate problems, and are they buried in false positives? Do your tools only spot legitimate problems? No, so we've confused the tools. Even they can't read your code, right? Do you dread making changes to some particular source files in a code base? Okay, programmers, can you name that file right now? A bunch of you can, and some of you can't. Businesslogic.cs. So, by definition, source code is a very precisely worded document such that the computers and the humans maintain a shared understanding. I know the computer doesn't know what it's doing. It's just mechanical. It's a moron. It just does what you said. But the idea is that what the computer will do is the same as what you understand it will do, and not just you, but everyone else in the code base. That's how precisely worded it is. And if you haven't been a programmer, you're going to be thinking, oh my gosh, this is like cross-species communication. This is some tough stuff. If the proper usage is clear, that's a good thing. If improper usage looks wrong, looks difficult, that's probably a good thing. So we want to not have errors and to make our changes quickly. Why does it take a long time? Well, it takes a long time because it's hard to tell what I need to change, and then it's hard to make it the change that actually does what we want it to do. And then when I do that, it's written in such a way that my code reviewer doesn't think it's good, and they have to go back and redo it again. So, a bunch of things make it slow. So Joel on Software, a long time ago, 2005, said, make wrong code look wrong. I think, wow, that's what readability is about. Make the mistakes look like mistakes. If wrong code looks wrong, it has a fighting chance of being caught by somebody, right? And that's the art. He has another little quote in there. He said, this is the real art, making robust code by literally inventing conventions that make errors stand out on the screen. This might be important. Strong typing, by the way. Do you guys fans of static typing or dynamic typing? Does anyone here like untyped and weakly typed languages where the value of something depends on the context you're reading it in? Everybody here a big fan of old-style Perl and maybe Bash? No, we like types to give us some protection. So, to capture the invariance of the code and exclude certain classes of programming errors. And I could talk about that for 3 days, but we have 25 minutes. But this is why primitive obsession is a code smell. Make a function that takes 3 integers. What happens when you get them out of order? Well, the first one's an ID. Okay, well, what's the second one? Oh, it's an ID to something else. And what's the third one? That's an amount of money. Yeah, getting them out of order. Will the compiler complain if you get it wrong? No, it'll just produce the wrong answer. or a crash. Okay, so in our old world, we believed that readability was like a skill that an individual has, and then the individual will imbue their creation with readability. They will transfer that readability from their imagination into the code base, and that code is readable or it's not readable. Brilliant idea. Absolutely, positively, mostly wrong. It's subtle. Okay, so suddenly everything's going to make sense to you because you're going to hear the sentence. Readability is an attribute on the relationship between a coding artifact, source file, and its audience. If it doesn't sound profound, it's because you haven't had enough time with it yet. It's a relationship between the artifact and its audience. Now, up in the very, very far corner, way over there, at the top corner of the audience, it says author. The author is only a member of the audience. The author is not the audience. How many conflicts do you get because I wrote readable code, I wrote it the way that I know is readable, and therefore it's readable? Okay, if it's not readable to everyone else, is it readable? If the rest of your audience can't read it, is it readable? And by the way, in the other corner underneath author, I put the computer because it still needs to be able to parse and execute. When you think about this, that means that readability has a social context, not an individual context. I'm an author. I've been writing code since 1979. Guess what? My code isn't automatically readable. I've been studying readability for a long time, and my code isn't automatically readable if I don't know my audience. If I join your team, I need to write your team's code, not my code. Interesting thought. So authors hopefully are members of the audience. It is subjective, but it's not individual. Code style is not an untenable, personal, subjective set of preferences. It is a social context. Interesting to deal with. Okay, so when comments are useful, they're not always. This is why. We can either change the code or we can prime the audience. If you know combinations from iter tools and you know data frames and you know default dictionaries, that code is really obvious. But you didn't. So I could have written a comment to explain to you what they are, but there's already documentation on that. Probably the documentation I wrote that you couldn't read was actually telling you the data frames are commits in the version control system, and the files are the files involved in each commit, and it's calculating the relative strength of the relationships between the files by accumulating them. So I prime the audience, now they can start to understand the code. That's a fine thing. So let's talk about typography and formatting. What's the correct way to indent your code? Where do the braces belong? Does anyone care? So John Cruz actually was replying to me on Twitter /X/ whatever the heck that is now, garbage dump. One rule of thumb I've used to refine my styles over the years is if I go and help someone having an issue, and after reformatting the code, they immediately spot their previously unseen problem, that's a sign of a better coding style. Okay, that's done. Been done with typography. That's it. Pretty much any non-pathological style works as well as it can if it makes your errors more obvious. Remember that your style preference is subjective to your audience, not just to you. If your language has a style guide, use that. And I'm done with typography. Let's go to naming, because this one we can spend more time on. I wrote that chapter of the Clean Code book. Later on, somebody came along and added more stuff to it. So if you look at the coding example that comes at the last part of that chapter, I didn't do that, I didn't approve that, and I don't even like that. I didn't like the example or the way it's solved. I'll show you my solution for it if you want to see it sometime. But I only recently found out that they had added to my chapter after I had given permission. So I'm a little upset. Anyway, originally there was the Ottinger's rules for variable and class naming. This goes back to the 1990s, early to mid 90s. Then later on Clean Code and Chapter 2, my name appears at the upper right-hand corner. Most of that, the important part, the part you like, that's the part I wrote. Agile in a Flash, we did another one. We put meaningful names. The name says what it's for, avoid encodings, functions, variables. It's basically the same stuff, simplified down. Later on, we published with pragmatic programmers, really meaningful names. We tried to make it a cheat sheet. If you have that particular volume, you can find that in there. Accurate, powerful, pronounceable, begin well, are simple. By the way, we tend to see the beginnings and the names and ends of names. So if you have a long name, which I don't recommend, and the only difference between 2 or 3 long names is somewhere in the middle, expect errors. Move the significant parts to the front or the back, and people will see them. We don't really look at the middles. Anyway, simple, depend on context, blah, 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 blah. Am I obsessed with naming? Yeah, probably. I will own that. Good naming powerfully primes your audience to understand your code. If I called it X1, X2, X3, X4, if all of my variables were the letter X followed by some number, it's the sequence at which it appeared, the compiler wouldn't care. The exact complexity of the code would be unchanged, but the audience would find it difficult. So naming is about priming the audience to understand the code, because it's an attribute on the relationship. So I think it's very powerful. However, it's also got a lot of problems. Synonyms, they're different words that mean the same thing. Polysemy is words with multiple meanings. Sometimes that's just even tenses, like read and read. Tough. Homonyms, different words with identical spelling, like read and read also. So as the names chosen by one developer may not convey the expected meaning to another developer. This is from an academic paper called How Developers Choose Names. You will find it to be true. That's why your audience matters. They use different words. It's almost like you have a dialect of Python for each Python project. And that's okay, right? They developed a 3-step model. We select the concepts that will be included in the name. We choose the words to represent each concept, and then we create a name, some concatenation of these words in some order. They found out that when people are actually concentrating on this and actually intentionally doing this, they come up with names that other people approve of. So if you need a process, but you know what? Nobody gets the right name first. Nobody does. You're going to have a name, and then you're going to get a better name, and then a better name. If you want to take a look, J.B. Rainsberger has this big hand-drawn chart where it starts on the left with, ill-conceived, bad names, and it ends up with really, well-accepted, beautiful names. Don't try to read this. It's too hard. I'll give you the slides later, and you can look it up there. Also, take a look at naming as a process. This is Arlo Belshi. It's not me, but he wrote up a series where we start with an obviously nonsense name, X, Y, applesauce. My favorite is poop, because that's a name you will definitely go change and get out of your code base. You'll feel the tension to find a better name. Then you make it an honest name, so it actually says what it does, and then you get completely honest, and it may be a long name at that point. That's a bad smell too. You finally get to a point where the name is doing the right thing, and then it becomes intention revealing, and then actually you change the domain, you change the way the design lays out so that you can give it a simple name that makes sense. So obviously there's design involved. When I can't name something, it's because the code isn't clear. That's the litmus, sort of like the reformatting rule that we saw earlier. If it makes the errors obvious, it's good. So, quick look, which of these is more obvious? Which do you prefer? Most people like the one line better. There's an interesting thing that happens when brevity aids readability. Sometimes it damages readability. But the idea is when you can take it in at a glance, you tend to do a better job. Here's too much code nesting and then less nesting. Take a quick glance at this. There's a whole article about this, code health, reduce nesting. Okay, what am I going to see there? Well, I don't like the arrow structure of the one on the left. I see indent, 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 but it's harmless, right? Okay, how many of you noticed this? We've got the error messages reversed. The unauthorized is being reported for the encoding problem, and the encoding error is being returned on the authorized error. It's backward, it's wrong. It's got an error. Did you spot it on the left? No, but you might have spotted it on the right. The formatting that makes the error more obvious is probably the right formatting of the different ways we can express this idea. Take a look at that one and the one before it. Clearly, those are swapped. I spotted the one on the right pretty quickly. Is it better that the key behavior is not indented? On the right, it's up against the left margin, which means it's in the main flow. Right? On the left, it's indented as deeply as possible, so it's an exception to the main flow. You have to have a bunch of conditions fall in before you can ever see what's going to be done. It looks like an exception. Well, maybe that's a thing, maybe it's not. Back to clean code. Here's my Python code example. You can actually read it. And what the heck does it do? Okay, let's keep the same problem. Let's play with it for a minute. This thing, list1 plus equals a list created out of X. What the heck is going on? Oh, well, if I take a value and I put it inside a list, then I can concatenate the two. I'm just appending. That is a weird way to append. That's physically more complex than the one on the right. Plus, it doesn't have a good name. So the one on the right immediately makes a small amount of clarity in the middle of some morass of messy code. By the way, idioms are good. Why? Because we're familiar with them. If you make a little change in an idiom, then people start to misread it. For instance, instead of being 0 and less than 100, it's 1 and less than or equal to. They found that people will make errors reading this code. Just any small change from the standard idiom could be enough to throw people off. Well, how about this one? If x sub 0 is equal to 4, what does the 4 mean? Well, it means that it's flagged. Okay, well, let's give that a name. We'll call it is flagged. Is that a little bit better? Not much. Okay, let's keep going. X sub 0, what the heck does that mean? Well, it turns out 0 is the status variable for this particular array. Well, why don't we just give it a name and call it status? So is this looking a little bit better? If the status is flagged, then we add it to the list. It's a little bit better. Okay. Why is this routine, that's a block inside of some other function, reaching inside the X item inside the list and pillaging and taking values out and comparing? Can't that do it for us? Why do we even do this? Okay, well, we'll do something better. How about that? Oh, wait, this isn't just renaming, this is now object design. It's the user experience of the code is, I can now say X is flagged, and I don't have to know that it's 0. I don't have to know that it's 4. I don't have to, right? I'm not pillaging anymore, so that's better. So now I know that the thing I'm returning is the list of flagged things. What are they, though? Well, I have to dig into the code a little bit more. It turns out they're cells. So these are the flagged cells. Okay, we seem to be going somewhere with this. What is the list? Turns out it's a game board. Does anybody know what program this is? Any guesses? Minesweeper. Suddenly the code looks like it belongs to something. It now has an identity. It means something, and you're now primed to understand the rest of the code in that code. If you're a Python programmer, you might like this. I'm going to conclude real quick with a couple other minor changes. By the way, there are design rules that we could go through, but how about this one? Instead of us filtering, could the Can we just pass the is flag to the game board? Well, that's pretty good, but maybe we can do better. How about if the game board contains its own filtered? Well, that's less for us to do. User experience is improved. But wait. Why are we doing this at all? Shouldn't the game board do this for us? I can replace that whole block of code in the middle of that big function with a call to gameboard.getFlaggedCells. Which one's more readable? The smiley one, right? The second one's a lot shorter, but there's much more than method length at play. There are fewer facts to hold in your mind as you're interpreting the code. The naming explains the state space and the intention, and off you go. Things are pretty good. Now, we are out of time, but I want to open this up and let you steal this. Take a shot of this. This is I have a blog called The Code Virtues Explained. Number one, code has to work. Otherwise, nothing else about it is even remotely interesting. So if they make it messy to make it work, that's a good start. That's table stakes. That allows you to play the game. Unique is next. Duplication just makes things worse. We could have copied that particular phrase a million places in the game sweeper code, but that would have made it just worse everywhere. So unique is better. Simple is objective, operands, operations, and paths. And then we get to clear, which depends on your audience. Easy to make changes to, depends on your audience. Developed is when we've gone from simple naming to object design, and we've now built a domain language that we need. And brief, we tend to find if you can take in an algorithm in a glance, that's better than having to back into it from 50 lines of code. That's all the readability we have time for. I thank you for your attention and your participation. And if you want to see the slides, let me know. I'll see you in LinkedIn and about the conference.